Okay, we're looking at section 9.4, applications, distance, rate, time, number problems, and amounts and costs. This problem says a furniture shop refinishes tables. Employees use one of two methods to refinish each table. Method 1 takes 1 hour and the materials cost $8. Method 2 takes 1.5 hours and the material costs $7. Next week they plan to spend 91 hours in labor and 518 in material for refinishing tables. How many tables should they plan to refinish with each method? So this problem and the problems in this section basically have the goal of taking the information and creating two equations that are like the two line equations that you would start with from previous sections, and figure out where those two lines overlap, and that will give you the number of tables that you'd need for each method. I'm kind of getting ahead of myself a little bit, because you might be like, well, how do you even know to set it up that way? The question is how many tables. So I think a number of tables should be represented with each of your unknown variables. In the tutor mode, I think it will say, yeah, it says let x be the number of tables refinished using method 1, let y equal the number of tables refinished using method 2, and then what you need to do are create two equations using that information. They kind of help you out here and say, well, you might want to do something about the total number of hours, because if it takes an hour to do the first method per table, and I do times the number of tables, x actually will represent a number of hours. 1 times x is still x. And then I'm going to add 1.5 hours times x number of tables will give you a total amount of hours by method 2, and that equals 91. So there's one, oops, sorry, I messed that up there a little bit. X plus 1.5 times y is the variable for method 2, equals 91. And then for the second part here, I could say that the first method costs $8 per table times x number of tables. Second method costs $7 per table times y number of tables, and that should equal the total dollar amount of 518. So those should be two equations that work. Okay, so far so good. Now they say at this point you can use this system of linear equations needs to be solved. You can use substitution or the addition method to solve. After you do this, write the solutions below. So they're not going to really help you from here in terms of telling you what to do. I would recommend just kind of talking through this, that you multiply, well, I guess it depends on the method. If you choose to do the addition method, I would multiply everything on the top here perhaps by -8. And what that would do is create cancellation with the +8 here when you add each column, and then you could go from there. If you do substitution method, perhaps to get the x by itself up here by subtracting 1.5y from both sides, and then you could work it. But what I'm gonna do is pause it. I'm gonna work this out on my own. If you need to go back and figure out how to solve these, you may want to refer back to the sections 9.1 through 9.3. But I'm going to focus more on how do you get to this point with these word problems, because that's the new content here. Okay, so I just paused it and just came back here. On paper, I worked it out using the substitution method. I subtracted 1.5y from both sides. I ended up plugging in 91, take away 1.5y in for x in the other equation. When I worked it out, I found out that y equaled 42. So that was the number of tables done by method 2. And then I plugged it back into one of the equations, and found out that the other case is that 28 tables was used for method 1. So remember, when you get these answers, you can plug them back in for x and y here, and you'd check and make sure, and you would get 91 there. And you could plug it back into the bottom one here, and you would get 518. So you can check your work and make sure that you did it right. And that's correct. Alright, this one says the sum of two numbers is 35. The sum of the smaller and 5 times the larger is 147. Find the numbers. So again, when they say, you know, here's the box, here are the boxes, what are the numbers, the larger and the smaller, right off you know what your x and your y are, or your two variables. You know what you're going to label them as. And then from there, try to construct two equations that use that information. So the sum of two numbers is 35. Right off, I know x plus y equals 35 is going to make sense, because it's those two numbers added together give me 35. And it says, a little more complicated here, the sum of the smaller and 5 times the larger is 147. But still, if we're calling the smaller number x, and then, you know, the larger number y, then we could say x plus 5 times y equals 147. And then we just got to solve it out. So I think that's fairly straightforward when they kind of write it out like that. But they labeled it in reverse, so we'll follow it the way they said. They said x is the larger number, y is the smaller number. Either way, it should work out the same as long as you're consistent with the smaller and the larger parts here. X plus y equals 35, and then 5 times the larger plus the smaller is 147, so 5 times x plus y equals 147. Okay, so that was done correctly, and then they just say, you know, give me the answers. So you have to realize that you can do substitution or addition method. Either way is going to work on this one as well. Perhaps you'd multiply everything on the top by -1, and what that would do is cancel out the y's. That's not a bad option there, and it would leave you with 4x here, and when this 35 becomes negative and gets added to 147, it's really being subtracted from 147. Ultimately, you'd end up with, looks like 112. So you could work it out from there and say 4x equals 112. And if we say, write that down there, 4x equals 112, if I divide by 4, looks like it would go in 3, let's see, 2, so 28 looks like would work. So based on that work, you could get 28 for the x value. That would be the larger number, and then just plug 28 back in, do a quick step of subtracting it from both sides. On the top equation, you should get 7 for the y value. Double check to make sure that makes sense. 28 times 5 is 140, plus 7 is 147. It checks out with both equations. This question is very quick. I'm going to try to squeeze it in for the sake of time. Two buses leave Charlotte at the same time traveling opposite directions. One bus travels 57 miles per hour, the other 62. How soon will they be 238 miles apart? If they're going in opposite directions, all you really need to do is say that basically that they have a combined rate of how they're kind of like leaving each other of 62 plus 57. I don't even see this as a problem the way they're trying to ask you to do it, because ultimately you add those two numbers together, you get 119 mile per hour difference, and then you should be able to divide that into 238, because rate times time is distance. You should get an answer of 2 when you divide 238 by 119.